electric field. Now when it comes to, or when it gets to electric field, okay, so I will explain a very great concept to you. Electric field, this topic is a very wonderful topic, and it's filled with a lot of calculations. So make sure you take your time to listen to this great video, and take notes where necessary, because this topic is filled with a lot of great points and possible exam questions. So firstly, I will say that electric field, or a field, is a region. A field is a region where where a force, you can say where a force is felt. So a field is a region where a force is what? Felt. So the field, there are different types of field. We have three types of fields. We have the magnetic field, we can have the magnetic, we can have the electric, and we have the gravitational. So our attention right now is on the electric what? Field. So you can say the magnetic field is the region where magnetic force is felt. The electric field is the region where electric force is felt, and the gravitational field is the region where gravitational force is felt. So now you also take note that how do we really identify an electric field? I'll tell you that if, for example, you have a transformer by your side, a transformer in your house, a transformer in your area, and you have a transformer there, will you go close to the transformer? Let's say this is the transformer now. You want to walk close to the transformer, will you just cross the transformer? We just go, when you know that it's having power, you just go touch it, go feel it? No, you won't. I don't think you will do that. But actually, because you already have the mindset that there is a field that is generated around that transformer, that is why you tend to give yourself a gap from the transformer, and that's as a result of what? The electric field that you already have in your mind. So I can say that an electric field, the best way to determine an electric field is via lines of force. So lines of force are usually what? Generated around the electric field. But how do you know about these lines of force? These lines of force, you take note that they are imaginary lines. They are imaginary lines drawn in an electric field, to help you know the direction of the field, to help you know the direction of field. So the best way to actually know an electric field being generated, or this is an electric field, or you want to feel the effect of an electric force or anything like that, the best way is to know it through the lines of force that are what? Generated around that field. And you also take note that these lines of force can actually be of two types. It can be uniform. The lines of force can be uniform, and the lines of force can be variable. So we can have uniform lines of force, and we can have variable lines of what? Force. Now, how does uniform lines of force exist? We explain to you now. The uniform lines of force, they are usually straight lines. You can say of this format. All these ones are the uniform lines of force. These are the uniform. Then if we're talking about the variable uniform lines of force, we're talking about the variable lines of force now. It's like curves. So you can say the variable lines of force are usually like what? Curves. Variable lines of force. So we can have various lines of force. We can have the uniform lines of force, and we can have the variable lines of what? Force. So uniform lines of force are usually straight lines, while the variable lines of force are usually what? Curved. So they are usually of curves and curved in nature. Now, so we can have uniform field, and we can have the variable what? Field. Now, I've already given you an insight onto how all these things work. Now you take note that positive goes outward, the negative goes inward. So if this is our positive charge, let's say this is our positive charge now. We're having a positive charge here. You observe that this is our positive charge. How does it work? Our field line is generated. It goes outward. You observe very well what I'm doing. Then negative. If this is negative, you observe that negative goes inward. So like I said, positive goes outward, then negative goes inward. So positive, we have positive, outward, then negative is what? Inward. So you take note, positive outward, negative what? Inward. Now another aspect is, like I said, when we were talking about electric charges, I said that like charges tend to repel, unlike charges tend to attract. Now if you observe very well, we have different types of lines of force. I said we have the uniform and we have the variable. You observe the lines of force now. Now you observe this one. This is positive charge. This is negative charge. Observe the lines of force. They are usually straight. This straight represents the uniform. And this is also straight. It represents the what? The uniform. Now, not for any reason will you will never see a line of force where they tend to intertwine in such a way that they tend to cancel out each other, or they tend to go through each other or pass each other. So just take note that they don't tend to cross each other. Lines of force don't cross each other. So let me just tell you about some rules. I'll tell you some rules or properties of feed lines. So you just take note of these feed lines, properties of these feed lines. Now the first one is, feed lines are generated from the positive. They go from the positive and enter the what? The negative. So lines of force start only on positive charges and end only on negative charges. So they start on positive, and end on negative. So lines of force starts on positive and end on what? Negative charges. So you don't expect it to start from negative to end at positive. No, they start from positive and what? End in what? Negative. Then you also take note that lines of force do not cross each other. Lines of force do not cross each other. So you don't expect something like this. You now have, maybe this is positive and something like this now. You now expect that the line will not come across this one, or cross that one, or cross this one. No, it does not exist. So lines of force do not, I underline this word, they do not what? Cross each other. And if they do, you observe that they do not, it does not make any sense. So take note that lines of force do not what? Cross what? Each other. Then in a uniform field, let's say this is our uniform field now. In a uniform field, lines of force can either be straight, they can either be parallel, or they can either be straight, they can either be parallel, or they can be uniformly spaced. So they can either be straight, parallel, and uniformly what? Spaced. So you observe there's usually spaces that are given between them. So they can be straight, they can be parallel, and they can be what? Uniformly what? Spaced. So you take note of these points. Like I said, lines of force do not cross each other. Lines of force start from positive and end in negative. Lines of force do not cross each other in a uniform field. They can be straight, they can be parallel, and they can be uniformly what? Spaced. Now, giving you so many rules you need to take note of. Now we'll go to current. I'll tell you about current right away. Now, under current, you take note that the unit of current is ampere. I think we did this during the laboratory aspect. The unit of current is ampere. So ampere is represented as A. The device used to measure current is called an ammeter. So the device used to measure current is called an ammeter. The device used to measure current is called an ammeter. And at some point in time, we may want to measure sensitive current. If you want to measure sensitive current, the device used is called a galvanometer. So the first thing is you take note that current, the unit of current is ampere. The device used to measure current is ammeter. To measure sensitive current, use a galvanometer. And sensitive current is also known as small current. So if you want to measure small current, use a what? A galvanometer. Also, small current can also be called milliammeter. Milliammeter, that's unit of small current, milliammeter, MA. And you can either have have that or not. Now, and a definition of current, I will tell you that current, if you want to define current, we can say current is the rate. Current is the rate of flow. Is the rate of flow of electric charge along a conductor. So I will say that current is the rate of flow of electric charge along a conductor. Now that means current. This current now that we said is represented as A now. Current in itself, the symbol for current is I. Say the symbol for current is what? I. And this current is taken as I is equal to Q over T. Is the rate of flow of what? Electric charges along a conductor. So I is equal to Q over T. And that means Q, if you cross multiply, Q is equal to what? IT. Now Q is equal to IT. Now if we've been able to get this aspect out, you, like I said, this one now is known as a electric charge. Q now represents electric charge. This Q represents electric charge. I represents current. And T represents time. This electric charge now, this current is taken as A. Time is taken as seconds, and this electric charge is taken as coulomb. Electric charge is taken as what? Coulomb. So we can take Q in coulomb. It's taken as coulomb. Look at the spelling of coulomb here. Coulomb is taken as this. This Q is taken as this Q now that is here. It's represented as coulomb. This I is represented as current. Then this T is represented as time, which is measured in what? Seconds. So you take note that Q is equal to IT. Take note that Q is equal to what? IT in this aspect.